So if we want to use the law of cosines to solve a triangle where we know one side, an angle adjacent to it, and another side adjacent to that same angle, that is, we've got side, angle in the middle, side, SAS, we have three steps, essentially. We want to use the law of cosines to find the side opposite of the angle, that is the last remaining side. Then, once we have all three sides and the angle, we use the law of sines to find the angle opposite of the shorter two given sides, where this is always an acute angle. And then from there, find the third angle by subtracting the measure of the given and the angle found in step 2 from the total, 180 degrees. So for our first example, we want to solve the triangle given here, where we have length B equals 7, angle A is 120 degrees, and C length is 8. So for this, we're going to start by using the law of cosines to find the value A using the angle measure A. Sounds confusing, but we're going to see what we mean here. We're going to take this first term there. We're going to say we want A squared is equal to B squared plus C squared minus 2BC cosine of A, where we have that B is equal to 7, so we have 7 squared, or 49, plus 8 squared, or 64, minus 2 times 7 times 8, B times C, times cosine of our angle A, which here is 120 degrees. Take all these together, and we will get 49 plus 64 equals, what would that be? You add those up, and you get 113. Meanwhile, over here, you would get 2 times 7 times 8, so that would be 2 times 56, or 112, but then you're multiplying it by cosine of 120, which is negative 1/2, so you would end up with positive 56. And if we want to just get A, then we would have the square root of 169, or 13. So we have that A is 13, means we have all three of the side lengths. So now we can work in terms of whatever we want in order to be able to get our angles using the law of sines, where by convention, so we can be repetitive, I guess, with our process, so we can get a sort of nice algorithmic approach. We always take the shorter side, but really we could use either. Here, what we're going to do then is to get the value for angle B, we're going to use the relationship that we have from before, that is sine B over B equals sine A over A, flipping over the law of sines for the sake of simplicity, which turns into sine B equals B sine A, that should be a small s, excuse me, over A. We actually know all of these values now. We have that B is one of our given lengths, 7. We're taking sine of 120 degrees again. And down here we have 13, where even though all of these end up being nice-ish values, unfortunately, division by 13 isn't so nice, and we get that our value here is approximately 0.4663. And then that means if we want to find B, we have that B is equal to, or more appropriately, approximately equal to, the inverse sine function at 0.4663, And the inverse sine function at 0.4663 will give an approximate angle measurement of 28 degrees. And now we're almost done. We move on to step 3, where our last step is to take the values that we have and use them to get the measurement of angle C, where angle C, angle C. I'm getting lost on these symbols just a little bit, because there are quite a few of them. It's easy to lose track. But we have C, the one we want, because we have B and A, is going to be 180 minus A minus B, or 180 degrees minus 120 minus approximately 28 degrees each time. So C, we're going to say it's equal to 32. Really, it's approximately 32 because it's approximately there, but there's a lot of approximation going on. Anyway, this is roughly the process that we have if we're given a side-angle-side arrangement. We take what we have, use the law of cosines to get our last side length, and then from there, it's a law of sines problem, actually. So law of cosines only really applies for one step. The main thing here is being able to recognize that we are given a side, angle, side. And our next example is going to be looking at what we do if we have just the side lengths, that is, side, side, and side, in terms of the law of cosines.